Fernanda Krupek. I'm an assistant professor and urban food system horticulturalist with the Department of Horticulture and Crop Science at Ohio State University. And we are here today at a cooperative of urban farms in central Ohio to talk about irrigation management in protected or semi-protected structures like high tunnels. So first of all, what is a high tunnel, right? High tunnel hoop houses, or in some regions, solar greenhouse might be called. Those are polyethylene covered structures as the one we are here right now, and is very common in urban areas as a season extension technique. So we know that temperature management is a key component in growing crops in high tunnel, but not only temperature management but also irrigation management is a key component and is the focus of this project. So when it comes to irrigation management, there are three concepts that is very important for us to keep in mind. One is field capacity. So essentially that's the maximum amount of water that a soil can hold. A second concept is the permanent wilt point, which is essentially the moisture content at which the plants are not able to absorb water and will experience wilting and eventually die if not irrigated. And then the third one is allowable depletion, which is essentially that moisture content in which the plants starts to experience some stress, and that's when we want to make sure that water is provided. So this allowable depletion is both crop dependent and also soil type dependent. And we know that in high tunnels, temperature management is a key component of maximizing plant growth, right? Because it's one of the key limiting factors for plant growth and development. But it's also important we monitor that soil moisture content throughout the growing season. And that's what we are doing with this project, where we are installing soil moisture sensors to track that throughout the growing season. And that is what is informing us the irrigation scheduling. So some details on this on-farm research project, right? So we are here at a co-op of urban farms in central Ohio, and we are comparing here two main contrasting irrigation scheduling methods. One, it's a farmer-led irrigation, essentially how the farmers have been monitoring or scheduling their irrigation in their high tunnel. And a second one that we are calling it a sensor-based irrigation scheduling. So we have here weather station and also soil moisture sensors that were installed in those beds where we are monitoring that moisture content throughout the growing season. And as you see here, we have tomatoes and peppers that are currently being grown in this high tunnel. And essentially, those two crops, when we look at the root architecture, based on some literature, we know that about 50% of the root system on those two crops are within the first 12 inches of soil depth. So that information informs us where we would place our sensors, right? So we have here sensors that were installed at 6 inches, so is the shallowest depth that we installed the sensors. And we are monitoring that soil moisture content throughout the growing season to inform when to irrigate. So we are collecting here not only information on soil moisture content, but also soil and air temperature throughout the growing season. And another piece of technology that we are integrating in this project is actually a Bluetooth valve in which the growers are able to manage their irrigation, turning it on or off by using their smartphone device. So essentially we are coupling information from the soil moisture sensors that is guiding the decision on when to irrigate the crop, and that can be done remotely through a smartphone device. So we hope that with this project, farmers are exposed to technologies and methods that can help them to manage irrigation efficiently and in a way that maximizes plant growth and productivity. So in summary, there are different ways a grower can manage their irrigation, right? And we certainly know that managing irrigation systems in high tunnel is different from an open field setting. So what we hope to accomplish with this project is being able to understand how high tunnel management affect, for example, soil moisture content throughout the growing season, and how that information can be used to guide decisions on irrigation management. So hopefully this will help growers to use data-driven farm management decisions, and also using technologies like the Bluetooth valve, where you can connect with a smartphone to turn irrigation on and off, can also save some time and labor on the workload of growers in the region. So if you have any questions about this project, please feel free to reach out, and stay tuned for upcoming updates.